Thank you.
And we'll just, I just keep in touch. Maybe we can find because
Not so much time, but we have a bunch of tools that would be on a web-based platform. And they're really useful for decision makers that can play with it even remotely.
Yeah, I'm more interested in that. Yeah.
So in the last 5 years, we developed a bit of technologies. So for the data crawling, so we have, for example, crawlers that get very early in the morning. And they download the last data.
Okay.
They are made available. It's not actually real time as we know, but they for energy systems.
That's good. That is good. That is close to you.
We have a platform for the security of oil supply when we track the routes of each energy tank, whichever ship, where they start from, where they get, which is the energy intake. And every day we download the routes of the previous day of all the ships.
Okay.
And then you can also risk analysis for the, say that the source country, which is the geopolitical instability risk, the countries, the piracy or the choke points. There's a lot of mathematical modeling.
Yeah, of course.
But it's just a nice screen, and first you can see the color of the road in red.
Yeah, but I really like that. I really like that because we haven't really taken that step yet. You know, we have all these models that used by
show that if you do a lot of let's say reports with many equations, many pictures, and many tables, it's not that useful for the high level. If you speak with the government, they need to have one page with this. If you do this, and then they can decide. And then, of course, there is a long explanation of the model used, but maybe two guys at the government are in the position to be able to read the data.
But they don't need it if they trust you. And if they trust science, that's okay.
So we need to let's say, to put down what we did.
And we know so much. You know, we know so much about how the energy system works now that we can try to implement more for the decision makers.
Yeah.
It might be more important than the incremental improvements. We ought to do that as well, but not all the time. Right? Yeah. So
I'm used to say that in the university you can do different types of research. One also curiosity driven. That is, I'm the professor. I set the problem. I solve the problem. I publish the problem, and I take the correct from it. The second one is distance-based. That is, somebody else has a problem. Me, I try to find a solution. I submit the solution to him or to us, and does it work or not? Both of them are interesting and perfectly fine with academia, but a little bit different.
They're a little bit different, a little bit about. But I won't steal your time. I see that here.
But I don't
or maybe
I can start.
I can just start with the shift.
Okay. Okay. So good afternoon to everybody. I would tell you something about what we are doing in Europe for the sustainability of the cities, and which is okay. So I was missing my chairman, but they asked me to start. Sorry. Okay, thanks. So I was saying I will try here very briefly to. Okay, doesn't matter. To tell you something about why cities are important for climate neutrality, which is the European vision about that. We have a mission for climate neutral smart cities, which are the shortcoming of the climate city contract that is the main tool for this vision. And then I will point out that we need a science-based approach for supporting the cities. I will try to draft a vision based on 4 pillars and discuss the role of the ontology and show to you a simple example of a tool that can be used to implement practically this vision. So if you think to cities, 65% of the world energy consumption is in the cities. More than 70% of global CO2 emissions are in cities. More than 50% of the world population will be 60 in 2030 and 75 by 2050 are in the cities. More than 80% of the global GDP is generated in the city. Nevertheless, the global surface of the city is only 3% of the global terrestrial area. That means the cities are very important. If you want to address the issue of climate sustainability and reduction of greenhouse gases, if you target the cities, basically you target the countries and you target the entire world. The large emitter cities in China, Shanghai, 400 something millions of tons of CO2 per year. Chongqing, Japan, Tokyo is 190. LA in New York, United States, around 100 million of tons per year. Korea and Russia, Moscow is around 70. In terms of per capita, for each inhabitants, again, China is on the top. Then we have United States with San Francisco and New York, but also Europe, a little bit less, but we are competing in this not very nice competition. If you look to this plot, you see red is China, the full bar is the absolute value, and per capita is the empty bar. Dark blue is the United States, the light blue is Europe. So you see the role that China and United States are playing, both in absolute values, but especially in terms of per capita values. And you see that especially for United States. If you look to the cities, we can also see that there are differences around the world in terms of which are the sectors more impacting. You see, we compare three cities, China, United States, and Berlin, so European Union. So the impacts are different. In China, the predominant role is played by industry in Shanghai. In United States, industry and power basically are responsible for 2/3 of the CO2 emissions. In new commercial and residential building would account for basically 1/2 of the overall emissions. In 2021, the European Commission launched this initiative that is called Vision Climate Neutral Smart Cities. The idea was to select, upon an application from the cities, 100 European cities plus 12 cities from associated countries that are expected to be climate neutral, very, very ambitious, by 2030. And the idea was to create in this way a kind of hub reference models for making all the European cities climate neutral by 2050. This was the huge challenge. Which is the tool for getting there? The basic idea is that they need to fill a climate city contract to be submitted to the European Commission. And after approval, they will get, say, kind of green label to be in this club of 100 cities of Europe. Already 33 cities got the label, more are working on that. So for doing that, the idea is to make this climate city contract that is basically structured in 3 different areas. One is called commitment. You need to have a co-creation process with different stakeholders, the municipality, the utilities, the big companies, the industries, the citizen, and to slide down a commitment to be climate neutral up by 2030. Then you have an action plan that is the list of things you need to do to fill the gap between where you are in terms of GHG emission and where you need to go. And then an investment plan in which you need to understand where you get the money. I mean, which is the public funds you can get and how you can get involved the private investors in this game. Which is the problem we are facing now. We started this process. We already cities that got the label, as I was mentioning. There is a problem that what is done is mainly an iterative patchwork of different actions. So the cities start to list small actions, something like a shopping list of things. I will put electric buses instead of diesel buses. I will do limited traffic areas in the city and so forth. So there is a lack of overarching strategy in doing this, and there is a lack of the consideration of the cross effects among different actions that are not even very well understood. Then there is another problem, this is the lack of common language. So we refer to different actions with the same name in Europe, and we have different names for the same actions. So when we want to make this club of 100 cities, we don't speak the same language. And this is a problem. There is also a lack of common trusted models. We make computation of the CO2 reduction for different action in different ways. And we don't share with models. They should be accounted for university and research center. And then there is the fact that the results lack of data for the calculation. So we need structured data to be used in this approach. I will provide to you two simple examples in two different areas. This is the electrification of private cars. You know, very important in Europe. The Commission said that by 2035, we will not be able anymore to sell diesel and petrol cars. So you need to cancel. There are a lot of, they are arguing on this. Maybe they will change. But this is the situation. So it's very important. Here I'm comparing Turku in Finland, Parma that is in Italy, Barcelona and Zaragoza in Spain, Stockholm in Sweden, and Klagenfurt in Germany. So this is how they react with respect to this area. I will not go into details, but look at the investment cost they put down, look to how they characterize the actions, and there is a very different way to consider that, and the actions are not even comparable at the European level. The electricity saw in the global trend, not every city considered explicitly the electrification of private car in the climate contract. Not every city considered the whole investment cost. Some of them just put the cost for the charging station, not for changing the car, because that will be paid by the citizen. And so you can argue if it is right or not. A second very simple example, building renovation. To make the building stock efficient. You know, we have another regulation issued last May, according to which by 2050, all the buildings should be zero emission, and there is a pathway to get there. I will not go into details. Again, you see how in different cities across Europe, there is a different idea in defining the action. Not every city considers this item in the action plan. Not every city calculated the investment for the single action. The unit cost, the cost for removing 1 ton of CO2 is very, very. So that was just to say which are the situation in which we are. The idea we are developing, I would say we are working on this also with Dr. Bottolon here, and we are working with other European universities, is to design a vision based on 4 pillars, the data management. We need to have a data lake house in which we collect, even with crawlers automatically, the data and make them available. The second one is we need to have an ontology. So we need to have a same language, and we need to define logic, which are the entities in the cities, and how to relate one with them. Then we have mathematical models for computing the CO2 and for CO2 emission or CO2 reduction, and also the investment cost. And this should be what we are proposing, and we are doing with some colleagues in other universities, an open library of function for Europe, and maybe not only. And then if you want to provide the tools for the decision makers, you need to have an advanced IT platform in which the decision maker can play with and get the way to see which is the best decision from them. They cannot read the long papers with many formulas. This is not useful for them. The data, of course, is important. So you have different data sets. You have crawler that can download the data from different formats. You need to validate the data. You need to store in a data lakehouse. And then you need to have a meta layer that is used for 2 main reasons. So the data you will collect are used for doing the tracking of the transition, where we are going. Are we getting to the equilibrium we want to get or not? So you need to rearrange the actions. And the second is the what if analysis. So I can say if I invest €1 in this action, I will save 1 kilograms of CO2. If I invest in another action, €1 will save 2 kilograms of CO2. And the policy decision maker needs to have a catalog of actions and compare them and select the one he or she wants to undertake. For this reason, it's very important, we said common language, it's very important to have an ontology of the city. We designed an ontology of the city based basically on these different city subjects: technology, infrastructure, social behavior, market, and those. So the city is characterized in the point in time by state. The state is how many CO2 we are emitting, which is the energy efficiency, how people is happy, how the people, I mean, if the people are happy or not, and whatever kind of cycle you want to consider. And we can track all the cause-effect relations that are triggered by an action. If you look, this is the ontology of the city subject, you see many different examples. We have inputs to the city, the energy commodity, the materials that can get into the cities. The city is intended to provide services, transportation, education, whatever. And the city is characterized by the state I was mentioning to you to the right. We do actions in such a way that we keep or improve the service, and we change, hopefully in a better way, the state of the city itself. So what is an ontology? You know, ontology is the science of being. In computer science, is a conceptual framework of a particular set of terms used to describe a specific domain of interest. It also includes a collection of unambiguous assumptions about the intended interpretation of these terms. Generally, an ontology is a formally defined vocabulary for a particular domain, in our case, the city. The relation among the several entities of an ontology obey to a prescribed set of rules. And so that is very useful not to have the confusion I was mentioning before. The ontology can be formally coded with a software, you know, for example, Protege from Stanford is one, but we have many of them. And so you can even code the relations and ontology for the city. Why we need an ontology? We need an ontology because the city is a dynamic complex system in the sense of the physics of complex system. So basically you have emerging properties. You cannot start with a single entity to understand the behavior of the world. You need to consider the emerging properties as they do in complex system physics. So this is a need. And then we need to track the transition. We need to consider the interconnection between city subject characterized by a set of entities. I need to be sure when I do a lecture against the city that I consider all the entities that are involved in different formalized body in body and should go be seeking this operation. Ontologies can be investigated by the user and provide the support for detecting relation crossing paths. Ontology may be even explored automatically. If you have the software, is what they call reasoning, so you can get all these implications in an automatic way, so very, very effective. I will not go into detail in the ontology. You know, we have classes, subclasses, we have infrastructure, then all the subclasses for infrastructure and the subclasses, and can be represented in a graphical way. This is an example of ontology for a city, but we have no time to go in more details. This is, for example, an action in which I say I want to replace diesel fired buses for the city with gas of electric buses. So you see how that will, let's say, evolve over the ontology we developed. Now I will go just to the end. I will try to keep it short as far as possible in such a way that maybe we can have a bit of discussion on that. The idea is the European Commission is asking us to make a climate city contract, as we said. So I need to provide a formalized document, but the document should be based on an ontology and a library of functions to assess from the, say, physical point of view, CO2 reduction, and also for economic point of view, which will be the actions and the path of action. So basically, we need to start from a baseline, that is where we are in terms of CO2 emission. Let's consider that the climate city contract is only focused on CO2 reduction. Is the carbon tunnel we heard at the beginning of this section. I don't say that is right, but it is what is in the understanding and in the request from the community. So we then define actions and pathways. According to the European terminology, a pathway is a policy. So in the set of action you group them there. We need to have a set of mathematical models that are related to the main 5 sectors that are involved. stationary energy, transport, waste, Apollo, agriculture, forests, and land uses, and energy system. The idea is that for each of these actions, I can develop a model, a mathematical model, let's say, as complicated as needed. And I can code that model in terms of a Python code or Julia code or whatever I like. Then I need to have a platform that is able to interact with the decision maker that doesn't know about Python, but can be confronted with a screen in which there are questions posed to him or to her. And so there is a JSON file that will say define how the platform would interact with the user, that is the policy decision maker. So the idea is to provide to them and advanced IT tools that is based on a web interface so they can access wherever they go on their computer or wherever, and they can play doing what we said before, the what if analysis. So I can design a very simple in the interface the action I want to implement. I check the effects, I check the cost, and so I can decide if I'm the mayor of the city, if I want to go that way or not. Just to show you a little bit how it works, the platform. So this idea to have the mathematical modeling, but not writing papers with equations, also that, of course, but to incorporate the equations in something that can be useful and user-friendly for a policy decision maker that not necessarily is an engineer or an academician. I show you briefly how it works, the vision I was mentioning. So this is the word, this is Torino, but this is very general. The data you will see here are dummy data. They are not referred to any specific city. This is just a summary about the vision. So you need to have open source model, mathematical model, and IT tools that can incorporate those models, to have an open library at the European level in which you can implement what if analysis. We need the ontology. We discussed about the ontology. And so we need to have a relation between entities in the city. And we need to be able to do the tracking of the city based on the data crawling to understand if we are going where we want to go or not. We need to have advanced tools to automatically collect, validate, store, and update the data. Now it's very popular AI. Everybody's using AI also here. I mean, to mention it, can be able to explore the data in a more with natural and more user-friendly way. And this is a little bit let's say, the policy from the academic point of view challenge, establishing community for doing that. Just to give you briefly an idea of which is the tool. So this is an example of IT tools you can access to the web interface, and it can be used from the decision maker to make analysis. So you have a geospatial representation of the cities. This is Torino, but could be whichever cities. You have the data behind that. So for each building, you have all the features of the building, which is the living system, the height, the geometrical dimension of the building. We connected that with a 3D model that is based on Google. So you can see the city is very deep from the geographical point of view. So you can explore and you can select the building and beyond all the data related to the building. You have different information. Those are the PV panels, even small, from 1 kilowatt installed in the city. You have the distribution system. You have the energy performance certificate for each building and some other information. For doing the climate city contract, you set an initial baseline where we have all the sectors and which are the emissions related to the use of different commodities. You can see that with a baseline that is a dashboard where you have the more impacting macro areas and the more relevant sectors in defining the carbon footprint. And then you can define very easily the different actions related to the ontology, so transport, private transportation. For example, this is an example in which the policy decision maker can go to the map of the city with the traffic flows and design basically there, and achieve with the network to resolve the errors of the traffic, and based on that, you get the computation of the cost. In this case, there are not basically cost and of the carbon footprint reduction. If you want to add a new function, because I don't know, we don't have a port that is a port, and you can add a Python file and the JSON file and make that available without the need for the policy decision maker to know all the equations. Okay, then you group together in the pathway of the actions and you see the results and you can submit your climate city contract. So basically, I went a little bit faster, and then you can even fill a draft of the climate city contract automatically. So everything is put in the format that the European Commission allows for the climate city contract. Okay, this is the dashboard in which you can do the tracking. So you want to go there in terms of CO2 reduction and investment, and you see where you are, where you want. I rushed a bit to provide you the basic ideas. This is all from my side, and for your.
So I'm taking the carbon footprint approach. I wonder to what extent is it possible to set climate footprint targets by individuals or neighborhoods, and then all of us have budgets, and then you get a subsidy if you meet your budget or below your budget and you don't. I mean, we know that carbon taxes are not possible, but maybe there's the incentive of, gee, I walk to the grocery store rather than drive. Meeting my carbon budget.
I would say there are two different ways. One important point is even when we speak about investments, the share of investments for carbon neutrality are not public investments, are private, even individual investments. We saw some large cities in no part of the world in which they say 100% costs for decarbonization, where example municipality. So the whole one is that there are ways. One is natural, so you need to explain the good things for your kids and carbon neutral, and it's one. The second one is privacy. Also, what is needed to be done is to study some kind of fixed more. I mean, there are to be some private investment, they can make investment, and they can get benefits that the state will recommend for you. So the investment from the private citizen to a company with local activity that can make some correction. With the well incentive for the panels in the utilities, the state allows to transfer their to the company, and then the investment is directly in their power. That's in general.
No, I always say to my students, we should be doing our classes at midnight, 2 o'clock in the morning. That's the lowest energy cost, and have siestas at 2 o'clock. You know.
But some years ago, there were in Italy some manufacturing companies. They convinced they make a deal with they convinced the workers to work Saturday and Sunday. Right. Instead, because of course, Saturday times the price of electricity and when some in the huge and you can share on that, I think would be all. I don't know if the students will have such a part.
Just a short question, taking over that presentation. What is the effort to replicate this city model to really to other arbitrary cities? It has to be some kind of tailor-made model, right? Because of the data. Or have you managed to make like error?
We are deciding with several European cities about this. So the template is exactly the same. Of course, the data of distribution network of fuel is different from the data from whichever other. But the template is the same, and the other way to connect the data will be the culture. Even if, for example, the speed that Google, the API from Google, it has from Google sitting on one hill also in the world. So, I mean, the technology is easily, let's say, applicable to different contexts. Of course, we should say that sometimes it's very difficult to get data quality. We did a special agreement with the, for example, we established a VPN and we get in the call out and the data about this, the risk in that we can use it for free. We need to go for the data in the video calls. But I think with some effort, it's doable. You need not to start from scratch every time. Thank you very much.